All right, welcome. Today, we're going to peek behind the curtain and decode the secret language that powers basically every app and game you use. We're talking about how they remember things, how they make decisions, all the good stuff. I mean, really think about that for a second. When you're in a game and your score goes up, how does it know? How does it keep track of your health bar second by second? It feels like magic, right? But it's not. It's actually a really clever and surprisingly simple system for storing information. Okay, so let's get into it. Let's decode this memory system, which is really the fundamental language of any interactive program you can think of. Because for anything to be interactive, to save your username or count your points or keep track of the items in your inventory, the program has to be able to hold on to that information. And, this is key, that info has to be able to change as the action happens. So how do they do it? What are the actual building blocks for that memory? Well, it all boils down to two core concepts that every single programmer uses: variables and constants. Let's break this down. Think of them like two types of storage boxes. On one side, you have variables. These are for info that's meant to change all the time, like your score. And on the other side, you have constants. These are for info that's locked in, the permanent rules of the game that should never, ever change. So a variable is just a label, a name, for a piece of data that you know is going to be updated. A classic example is score equals 0. It has to start somewhere, but you fully expect that number to go up. Or think about your avatar's health in Roblox. That is definitely a variable and one you're hoping doesn't change too quickly. And a constant is the total opposite. It's a value that's meant to stay the same, a fixed rule. Now, in Python, there's this little agreement, a convention, where you write constants in all capital letters. It's like a signal to other programmers that says, hey, this is a rule, don't touch this. Something like max_health equals 100. That's a core rule of the game world that you don't want anyone messing with. Now, these little storage boxes can hold different kinds of information. You've got strings, which is just programmer speak for text, like a player's name. You've got integers, which are your whole numbers, perfect for a score. Then you have floats for decimal numbers when you need that extra precision. And finally, you have Booleans, which are super simple, just true or false. Is the player alive? Yes or no, true or false. Okay, enough theory. Theory's great, but let's see how this stuff actually works. Let's put this logic into action inside a game. First things first, let's imagine we're building a feature for a game. Maybe something like PUBG. At the end of every single match, we need to calculate the player's final score. So how do we pull that off? This is where variables are just absolute magic. We create a variable called kills and another one for assists. The game rules, 10 points for a kill, 5 for an assist. Those are basically our constants. And the code just does some simple math. It takes the number in the kills variable, multiplies it by 10, takes the assists variable, multiplies by 5, adds them together, and boom, 65 points. It's clean, it's simple, and it works no matter what the player does. Okay, next up is a classic programming puzzle. It sounds simple, but it trips people up. You've got two players on a team, and you need to swap their positions. How do you do it without accidentally deleting one of them? So here's the trick. You can't just move player B into player A's spot because that would just overwrite A's data completely. Poof, gone. So what you do is you create a third temporary variable. Think of it like an empty holding spot. First, you copy player A into that temp spot. Now, player A's original spot is free. So you move player B into it. And for the final step, you take that original value you saved in temp and move it into player B's spot. It's a simple 3-step shuffle, and it works every time. And for our last little logic challenge, let's say you're building a matchmaking system. Before you can even start making teams, you've got to figure out a really basic question. Do you have an even number of players or an odd number? The secret here is that little % sign. It looks weird, but in programming, it's called the modulo operator. And all it does, it just gives you the remainder after you divide two numbers. So if you take the total number of players and divide by 2, and the remainder, the leftover, is 0, well then the number has to be even. It's such a clever and simple little trick for building out that pairing logic. And just like that, you've actually built up a really powerful little toolkit. You've got variables for things that change, constants for the rules that don't. You can use math to calculate scores. You can swap values to switch around roles. And you can use logic checks to make smart decisions. I mean, these are the absolute fundamental tools behind pretty much any game mechanic you can imagine. So we're moving from just learning about code to actually thinking about creation. What can you really build with all this? And this is why it matters. This isn't just some abstract thing you learn. This is your launch pad. That simple idea of a variable, that's your foundation for building real game logic in Roblox Studio. That logic check for even and odd numbers, that's what you'd use to build a K-pop fan voting app. All of this stuff, from a merch shop to a match calculator, it all starts with the exact tools you just learned. You've just learned the first few words in the language of creation. You now know how to tell a computer how to remember, how to calculate, and how to decide. You have the building blocks. So the only real question left is, what are you going to build first?